Hey everyone, welcome. Today we're tackling a really interesting Leetcode problem called number of zero-filled subarrays. It sounds simple, but there's a neat trick to solving it efficiently. We'll break down the logic step by step. Alright, so here's the official problem statement. The goal is pretty clear. We're given an array of integers, and we need to find out how many subarrays, that is, contiguous chunks of the array, are made up entirely of zeros. First, let's make sure we're on the same page. A zero-filled subarray is just a continuous sequence of elements inside the main array that only contains zeros. So for this example on the screen, a single zero counts. A block of two zeros also counts. But as soon as any other number gets in there, it's not a zero-filled subarray anymore. Our job is to find the total count of all these valid zero-only chunks. Let's try to count them ourselves to find a pattern. Imagine we just have a small array of 3 zeros. We can have subarrays of length 1, and there are 3 of those. We can also have subarrays of length 2. There are 2 of those. And finally, one big subarray of length 3. Adding them up gives us 6. So, did you notice the pattern? For a block of 3 zeros, the count was 3 plus 2 plus 1. For a block of k zeros, the total number of subarrays is always the sum of all integers from 1 up to k. There's a handy formula for this, which you see on screen. We could use this, find a block of zeros, measure its length, plug it into the formula, and add it to our total. But let's explore a more dynamic approach that doesn't even need the formula. Okay, what if we just scan the array from left to right and keep a running total? Let's use that 3-0 example again. When we see the very first zero, our streak of zeros is now 1. That single zero forms exactly one new subarray, so our total is 1. Then, we see the next zero. Our streak is now 2. This new zero creates 2 new subarrays that end at its position, the single zero by itself, and the block of 2 zeros. So we add 2 to our previous total. Finally, we hit the third zero. The streak becomes 3. This creates 3 new subarrays that end right here. The single zero, the block of 2, and the block of 3. So we add 3 to our running total, and we get the correct answer of 6. This is the core logic we'll use. So here's the complete plan. We'll go through the array one element at a time. We'll use a variable to keep track of our current streak of consecutive zeros. When we encounter a zero, we increase our streak count, and then we add that new count to our grand total. If we hit a number that isn't a zero, it breaks our streak, so we just have to reset our streak counter back to 0 and continue. And here's what that logic looks like in Python. It's really clean and simple. Let's quickly break it down so every part is crystal clear. First, we set up 2 counters. The one called total subarrays is what will eventually return, so it starts at 0. The other one, consecutive zeros, is our streak counter. It also starts at 0, because we haven't seen any numbers yet. Now we loop through each number in the input list. If the number is a 0, we do 2 things. First, we increment our streak counter. Let's say it just went from 2 to 3. Then, we take that new value, 3, and add it to our total subarrays. This simple addition is what correctly counts all the new subarrays that end at this position. The other case is simple. If the number is anything other than 0, our streak of zeros is over, so we just reset the consecutive zeros counter back to 0. This prepares us for the next time we might encounter a new block of zeros. So how efficient is this solution? For time complexity, we get big O of n, where n is the number of elements in the input list. This is because we just make a single pass through the array. And for space, it's big O of 1. Or constant space. We only use a fixed number of variables, like our 2 counters, regardless of the array's size. It's a very efficient solution. So let's recap the main points. This problem boils down to counting subarrays inside blocks of zeros. We saw that for any block of k zeros, there's a predictable number of subarrays inside it. And the most elegant way to calculate this for the whole array is to just do a single pass, keeping a running count of our current streak, and adding that streak length to our total every time we see another zero. Hope that breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. And hey, if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.